Welcome to lecture 9. My name is Professor J. N. Mandal, Indian Institute of Technology, Bombay, Mumbai, India. The name of the course Geosynthetics Engineering in Theory and Practice. Now we will address Module 2 Lecture 9, an overview of geosynthetics. Now recap of previous lecture which we have covered, that is design example, sustainability using geosynthetics, application of sustainable geosynthetics in various infrastructure. Today's lecture is mainly on major application of geosynthetics. Geosynthetics application for railroad, geosynthetics to deal deflection cracking in pavement, geosynthetics application for hydraulic structure, geosynthetics to mitigate coastal and river bank erosion, geosynthetics application for food and agriculture, geosynthetics application in mining engineering, geosynthetics application in tsunami, geosynthetics application for wastewater treatment, geosynthetics for landfill as early warning system for rain triggered landslide and debris flow, geosynthetics application as noise barrier to combat or mitigate the act of terrorism and or natural disaster. So there are many applications, and I will just address first the geosynthetics application for railroad. So geosynthetics is maybe in the form of geogrid, geotextile, geocomposite, geocell and geotextile tube can be effectively used for separation, filtration, drainage and reinforcement for railway rehabilitation and new railway track construction. Geosynthetics can be placed between the subgrade and the ballast in railway. It is needed to provide very good drainage and filtration, improve the load bearing capacity and reduce the settlement. The geosynthetics should be designed properly so as it can resist the tear, puncture and burst. Also geofoam can be used to construct the railway tunnel. You will look at this picture, that what is the geosynthetics material is placed between the subgrade and the stone ballast. Beneath the stone ballast, upon which that wooden, what is called wooden or the concrete tie is placed, and the design also should be very site specific. Sometimes what will happen, that there is a possibility for the level sliding of the aggregate, so there will be a devastation. So we can also provide the a kind of the gabion. You can see here, this is the gabion, and this gabion is looks like this, this is you can see that hexagonal mesh, and this is galvanized mild steel, and this also covered with the PVC, so there will be no formation of rust, it can be protected. And this kind of the gabion, you can have defined size and the shape, in general that 1 meter by 1 meter by 1 meter cube, and the top side is open, and you can fill up with the good quality of the aggregate, compact it, and then top portion of the lid it can tighten, and you can form a kind of this gabion. So this kind of the design should be site specific, and you can use this material as a separate in the re-evaluation for any road between the old containment and the ballast new. Sometimes also you require that you can remove all the contamination of the aggregate, and you can place the geosynthetics material, and then you can provide with the new ballast material or new aggregate. So this geosynthetics material act as a separation function, it also act as a filtration function, also act as a drainage function, and also geocell like or the gabion type wall also can act as a confinement function. So sometimes water may penetrate through the geotextile to the subgrade soil, or sometimes there will be the excess pore water pressure development below the subgrade, and it will move to upward to the stone ballast, and there is a possibility for the collapsing of this railroad. So if you can provide with the proper kind of the geosynthetics material, so it will act as a good filtration and good drainage material, and also there will be no mixture between the two dissimilarity kind of the material which is lying between the soil subgrade and the stone ballast. Apart from this, you can look that here in this example that how the geosynthetics material is acting so many functions at a time. It acts as a separation function, it acts as a filtration function, it acts as a drainage function, as well as it also acts as a confinement function. So that's why it is called multi-functional application. Next, geosynthetics application for reflection cracking. So reflection cracking is a great concern in highway and road of any country. Geosynthetics act as barrier in many projects. The use of geosynthetics does not give satisfactory result, because the proper selection, specification and installation of geosynthetics are very much needed based on the type of crack pattern. If the geosynthetics is introduced as reinforcement and barrier, it reduces the thickness of the pavement. I showed you also in my earlier lecture how the thickness also drastically reduced due to the presence of the geosynthetics material. Also cost as well as to improve the lifetime or durability and performance of the pavement. Now reflection crack prevention in pavement overlay. Look at here, that if this is the pavement and there is a possibility of different cracking pattern of the road surface. So, it is required to resurfacing the existing pavement due to excessive crack. So, this is the crack. So, we provide the bituminous overlay in general ranging in the thickness of 25 to 100 millimeter in the traditional method, and crack in the original pavement then reflect up through the new overlay. So, again there is a possibility for the formation of crack on the surface of the road. Therefore, it is required to provide a strip of the geotextile have been placed over this crack. You have to place a layer of geotextile material at the top of this crack. So, there are different types of the geotextile material can be used. It may be the geogrid, it may be polyester geotextile, or it may be polypropylene. Geotextile, polypropylene geotextile, and also fiber glass geotextile. Fiberglass geotextile. So, this is a geotextile sheet have been impregnated with the asphalt cement or asphalt emulsion. So, this will decrease in the thickness of the overlay and increase the lifetime of the overlay. And main function of this geotextile material as a reinforcement, that means tensile strength of the geotextile or geogrid or glass grid, and also it function is as a moisture or the waterproofing. So, what is to be done, that initially you have to clean this or the crack. Of course, the selection of the geotextile material depend upon the type of the pattern of the crack, whether it is in the longitudinal direction or transverse direction, or there is a alligator cracking. So, based on the pattern of the crack and the width and the depth of the crack, you have to select the geotextile material. Now, when there is a formation of the crack in the existing pavement, then you have to thoroughly clean this crack, and then you have to fill up with the bituminous on the pavement. Then you can spray the asphalt base on the existing pavement. Then you can place a layer of the geotextile material. This is geotextile material. This is to be placed. then the hot mixed bitumens and the overlay on the top. So, what will happen if there is no geotextile material, then crack will propagate and will appear on the surface of the pavement. When you are introducing a layer of geotextile material, then the crack will propagate up and arrested by the geotextile material and propagate on the other direction. So, then you can solve this problem, the reflection cracking problem, and how geosynthetics can help you to mitigate the reflection cracking on the pavement. Now, geosynthetics application for hydraulic structure. Geosynthetic can be effectively used in hydraulic structure, such as for the construction of the new dam, canal, retrofitting of aging concrete dam. So, you can use the geosynthetic material for the new dam. You can think about dam, it is a huge quantity of earth is required, huge quantity of concrete is required if it is a concrete dam. So, where the geosynthetics can drastically reduce the volume of the soil, volume of the concrete, and also if there is any problem with the existing concrete dam, and then how you can retrofitting, how you can repair the existing concrete dam. So, we have the geosynthetics material in terms of permeable material as well as impermeable material. In such cases, we can use the impermeable material, what you call geomembrane material, to protect the water or to control the seepage, and also sometimes we can also use the permeable material like geotextile, either it is woven and non-woven, for the proper filtration and the drainage. Particularly geomembrane or geosynthetics clay liner as impermeable material can be used on the upstream face of the dam as hydraulic barrier. Geomembrane can also be used to prevent the bank erosion of canal. Sometimes geomembrane may be damaged due to the puncturing. In such case, geotextile can place over and or below the geomembrane to prevent the punching. Here geotextile act as a cushion, as I showed you earlier lecture in case of the tunneling. So, here you can see that how the geosynthetics has been used in the hydraulic structure. This is the clay overlay and this is the core, and here is the geosynthetics material. This is as a chimney den and geosynthetics material or as a gallery it has been used. You can see this material is core. So, you have to check that what quantity of water passes through this. So, you can calculate that what will be the water flow. So, you can draw here in the core zone that flow line. You can draw that flow line and the equipotential line, and the combination of flow line and the equipotential line called the flow net. So, if you know that what is that quantity of flow of water passes through this area, because you know that what should be the permeability of this, and you know that what will be the hydraulic gradient, and you know the area. So, you will be able to find out that what quantity of water passes through that, and then how the geotextile can help to drain it out from the dam, and there will be no development of pressure here. So, you can see that how the geotextile material can help for the filtration and drainage in a dam. Also, we can see here, this is the number of the layer of the geogrid reinforcement in the upstream slope. Okay, this is the water level, this is the upstream slope, and this is the earthen dam section again, and then you can construct this dam using this number of layer of the geogrid material. We will design later about how to slope design is to be designed, and then in the front slope you are providing with the geomembrane or geosynthetic clay liner, which is an impermeable material. So, you can see that geomembrane will act as a barrier. Okay, so, you can make any slope or angle. What I am trying to focus sometimes here, that when you construct a dam, you need the huge quantity of the earth. So, instead of this kind of dam, you can make the dam, you can make like this. So, you do not need this quantity of the soil, huge quantity of soil, you can remove it. You can place a different layer of reinforcement material. You can make this is the defined layer of the reinforcement. Material. So, you can make a stable dam like this. Okay, you are saving huge quantity of the soil, which you have to transport some place, then you have to compact, etc. Alternative, you can see how you can use geogrid, you can make a almost like a 90-degree reinforced soil retaining wall, and you can provide with the geomembrane in the front. Okay, you can save. So, it will be the more economical design. So, next is geosynthetics application for coastal riverbank erosion. Geosynthetics can be effectively used for erosion control. To replace the conventional graded granular filter, geosynthetics must retain soil particle, that is filtration, and allow water to pass, that is what we call drainage. It can be used below the hard armor or riprap in a coastal riverman, lake shore line and channel, for scar protection around the structure such as beach piers and abutment, as well as for slope protection to prevent erosion from surface runoff and for bank protection. Three-dimensional geosynthetics erosion control mat are also used to retain the soil and moisture to promote vegetation growth. Roots can grow from vegetation and reinforce the mat. You can see that some of the slide, this is a cross section of the stream bank revetment, and this is also geotextile concrete matrices for slope protection. So, for example, that in a slope, suppose it is a river bank one protection, this is a river bank protection, the water level somewhere here, and this is the subgrade. So, what we do conventionally, provide some kind of this armor or the stone, like this, you can provide 2 layer of armor like this. So what will happen from here, the subgrade, that there is a development of excess pore water pressure, and then the whole system will damage. So many cases in the road or in this kind of the slope in a river or in a seashore, so you can provide this 1 layer of the geosynthetics material. I can show you some other color. You can provide with the here in between the subgrade and armor stone. So this is geosynthetics material. Okay, you are providing this as a geosynthetics material. So what will happen, that whatever the excess pore water pressure developed from bottom to the top, and this excess pore water pressure will divert it through the geosynthetics material, where this geosynthetic material act as a separation, at the same time it act as a filtration and drainage. Sometimes you can see there is a flow wave, and what will be the height of the wave, whether it is a laminar flow condition or it is a turbulent flow condition. So when you design this, so you have to be very careful that whether you are designing based on the laminar flow, whether or you are designed based on the turbulent flow. So accordingly you are to design. And also this side, back side of this, you can wrap like this, you can wrap like this, you can wrap like this, and then you can fill up with the armor stone like this. Okay, you can put on the top, so it can be act as an anchor, and similarly on the top side also you can place the geotextile material, then you can place this armor stone like this, or you can make a trench also like that, where this geotextile material also can be placed like this and can be covered like this, and it can be filled up with the aggregate, okay, to make it stable. So you can see that how this geosynthetic material can be used for the erosion control. Also that geotextile concrete mat slope protection. Somehow also you can use, if there is a slope, it is nothing but a kind of the gunny bag. Okay, this kind of the gunny bag, and this is the geosynthetics material, and this is filled up with the concrete, and this also can be placed along this slope. So here geosynthetic concrete matrix can be used for also slope protection. You can also use some kind of the slab, prefabricated concrete slab, and below the concrete slab also you can place this geotextile material. So there are different types of the system, different types of the material can be used for the erosion control. Now geosynthetics application for food and agriculture. You know that seepage loss in pond, canal, concrete tank and the ditches is about 30 to 50%. Water is costly and scarce, particularly in the drought region. The surface water and groundwater become polluted due to the animal waste. In arid region, farmers need water to preserve or store in reservoir, pond, canal, storage, tank and water harvesting catchment in order to supply for farm use. So, how the geosynthetic material used for the agriculture? The use of geosynthetics can save valuable water and environmentally control the polluted groundwater and surface water. Geomembrane or geosynthetic clay liner can also be used to replace or repair the old cracked concrete canal to prevent the water seepage loss. I have already mentioned earlier that if there is a crack formation, how we can use this geomembrane material or the geosynthetic clay liner. Biogas is generated from the animal waste and used to produce electricity for farmer. Geosynthetics can be used to cover the lagoon for biogas collection. There are many use for the geomembrane or geosynthetic clay liner. Here you can see that on canal section where you can place that red color is the high density polyethylene geomembrane, or you can use the geosynthetic clay liner cell, or you can use the geocell for steeper side slope and erosion control, and there will be no seepage. Okay. So, how you can apply this geosynthetics in agriculture? Then you can make use of the water for the agriculture purpose. Also, you can use this geosynthetic material for the cultivation purpose. There is a small kind of the tube which it can be passes through the agricultural land, and from some sources of water can be just to pass through that tube, and it is a kind of oven geotextile material. It is in the form of tube, and water can be passed through that tube. It is a kind of oven and material, so it has a apparent opening size or equivalent opening size, and waters can spread across the agricultural land in different location. So, you need sometimes that proper quantity of water for a particular plant. So, you can also distribute the water accordingly. So, this is also one way you can use the geosynthetic material for agricultural purpose. Also, about the cow dung also, you can protect the huge quantity of cow dung in USA, then you don't know how to control it, and then also with the use of the geomembrane it has been controlled, and from that cow dung also they can use the biogas or electricity. A geosynthetic application for mining engineering. Geosynthetics can be effectively used in mining industry for bulk storage system and handling. It can also be used in slot storage system as well as to prevent the landslide. You can see the left hand side the linear liner design for mining application. This is after Lupo and the Morrison 2007, where you can see that here there is a subgrade and how this geosynthetic material or the geomembrane material is used, and you can see that this is the all kind of the mining ore is here. So, it should be contaminated the ground. So, that is why you are providing a layer of the geomembrane material to control the seepage. Also, right hand side you can see the reinforced arch. This is after Vienna 1972. Even then below the mining So he can construct a tunnel like this, and this is the reinforcement. This is the reinforcement, and he can make a stable structure, because in the mining sometimes most of the time this kind of the tunnel it collapses because for instability of this tunnel. So he can provide with this kind of the reinforcement material, the metallic reinforcement material, and also he can form a tunnel and people can easily go and come, and he can make a much more stable reinforced arch. Now this is geosynthetics application for tsunami. Geosynthetics have a very important role for the protection, mitigation and rehabilitation of the coastal area damaged by the recent devastation due to the tsunami. Geosynthetics can act as a reinforcement, filtration, drainage, protection and barrier. Geosynthetics can perform erosion control, strengthen the retaining wall and embankment, as well as resist the catastrophic failure occur due to the strong earthquake associated with the tsunami. So how you can control this? You can see that this is near to the seashore, where you can construct a reinforced soil wall. This is the reinforcement, and there is a development of the pressure, and which can be controlled by this facing element. Here most typical, this is the facing element, this is the wave is act towards this facing element. Now if you simply can place this, if you can simply place a concrete like this, and this all the wave, when it will attack this facing of element which is made of the concrete, because this is rigid and there is a possibility for breaking this kind of the concrete, and because of whatever the force applied on this concrete, it is direct applying on the concrete, and this is the rigid, so most of the time it failed. Alternatively, if you can provide with a kind of the semicircle concrete block like this, so whatever the force, then it should be diverted like this. So you can minimize the wave which is attracting here, and also same time you are providing with a layer of geofoam material here. This is the geofoam material here. This is the geofoam material. This is the geofoam. This is geofoam. And this is the concrete. This is the concrete block. So, and when you are placing this number of layer of the geogrid material here, so you can see that when any pressure attack this, and this geofoam material has a very good compressibility characteristic, so it can be resisted by the geofoam material, and also at the same time the lateral earth pressure can drastically reduce. So we can adopt this kind of the system to protect the tsunami, and most of the time you can see that when the tsunami comes and the people run away, they don't know what to go, what to run, what to stay. So you can construct a kind of this kind of the structure near to the seashore, and it is very simple, very simple. So you can place this normal geotextile material and can wrap it like this, then you can make like this, then you can make like this. So any height you can construct like this, and these are all soil filled up with the sea material you can fill up with the sand, you can make it like this, like a wrapping system of wall. So this also we will study. So near to the seashore you can construct a wall like this, and people can go up very fast, can go up and the top of this, and you can make a shelter there also, house for temporary to protect themselves. Most important that how you can protect the people. So you can easily construct this kind of, this is the geosynthetics material, this is a flexible material, this may be the woven and non-woven geotextile material, and you can have locally near to the seashore sand, you fill up and construct this wall, and on the top you can make a house or something, shelter. So as height as you can do, and at least people can and can stay here, and this is much more stable structure, because even then the water comes, because this is for filtration and drainage, this is nothing will happen. So most important that how to protect the people, this is very very important, to save the people, to save the life of the people. So this kind of the system can be useful. So geosynthetic application for wastewater treatment. Geosynthetic can be used in various projects for wastewater treatment, such as dewatering municipal and industrial sludge, liner and cover system, evaporation system, and animal waste and marine waste. Geotextile tube is made of woven and non-woven geotextile material, is a permeable membrane and can be used for sludge dewatering. The geotextile tube has a very good filtration property. The sludge with high water content can be inserted into the geotextile tube and dry them rapidly to a solid state. The geotextile tube with desert sand can also be used to build the dike and drains. You can see this is a geotextile tube, and that you have to fill all kind of the draining material and fill it to the pipe, pumping and fill up. This is nothing but a tube, and then it can be filled up. This is a filling pot also. So this is the length of the geotextile tube, and fill up, and then you can apply the load, and then the water can be coming out from the geotextile tube. I will later also explain more about this. You can see here, for example, this is the Powai Lake sedimentary slurry. So this is the desert carter head, and this is all sedimentary slurry, and then you can pump it out, and pumping through the pipeline, and this is the geotextile material. This is geotextile material, and you are applying some load here, and at the base you are providing with the geomembrane material and the geotextile material. So due to the geomembrane there will be no loss, no water can percolate through this. All the contamination or the deserts, dirty water, contamination water which it can comes out from the geotextile tube due to the application of the load, and then it can be drained it out to the water treatment plant, and this drainage pipe for the water treatment plant can be made, and you can have a very clean water for use. So also this geotextile tube also you can put to the near to the for example that Powai Lake, whatever you can make it is a lengthwise geotextile tube. You can insert the all kind of the contaminated here, and then you applying the load, and then water can be drained it out, and the surrounding area of the Powai Lake you can provide with the kind of the line which can be drained it out. After the passage of time you can see this Powai Lake is absolutely clean, and this geotextile tube you can keep it as it is, then one after another you can also construct this embankment. So you are using this all kind of sediment here, pumping it to the geotextile tube, and then you are applying the load. So you can use both as a geotextile tube for the construction of embankment, and also you can protect the lake. So geosynthetic application for sustainable waste management and the landfill. 77. Now I will begin geosynthetics application for sustainable waste management and landfill. 70% to 90% of the landfill are open dumping in India, Viswanathan et al. 2003. It creates environmental pollution in water, land and air. During heavy rain, it also causes the drainage difficulty and leachate. Proper plan, liner and monitoring oil system are needed to check gas or water quality. It is also require leachate detection, collection, removal and treatment system. Only in Mumbai, municipal solid waste generated is about 6,500 metric tons per day. 5% of total waste is segregated by rag picker, only 7% is treated and disposed of scientifically. Each year, e-waste generated in India are more than 1,46,000 tons. Mumbai generated 23,000 metric tons of e-waste per year. It leaves behind carbon. Central Pollution Control Board CPCB 2012 and Ministry of Environmental and Forest 2010 reported that in India total plastic generation is 5.6 million ton per year, out of which 60%, that is 3.36 million ton per year, will be collected as plastic waste for recycling process, and 40%, that is 2.26 million tons per year, will be remain as uncollected plastic waste. So we also show later on that how we can use that plastic in different projects. So it is a major threat to environment and health hazard to the humanity and animal. In modern landfill, geosynthetics can provide cost effective long term environmental friendly engineering solution. Need for proper rules and regulation governing the construction of different type of the landfill system. Pay as you throw. So this figure you can see that leachate formation causing the contamination of groundwater and surface water. You can see this is all kind of the waste material, and this drop, if you don't provide any kind of the geosynthetic material, there will be a surface runoff which can be drained it out. The surface water will be contaminated, and also from the waste material it will pass through the ground, water will be also contaminated and leachate also will form. And if in the waste material there is any formation of the gas, then gas will move to the air. And sometimes also you can see some birds also appear in the landfill side. There is a dust, there is a sometimes fire also happens in the landfill, that also the fire hazard, and also there will be the precipitation. So you need to control if there is a formation of the leachate, and that due to happen due to contamination of the groundwater and the surface water. So you can provide with, at the base you can provide with the geomembrane material, geotextile material. You can provide with the kind of the geopipe material at the base, which you can protect the contamination towards the ground. So geocentric material system can protect in the landfill, and at the same time you have to provide the top with the cover where you can use the impermeable material, drainage material, and then you can cover with the soil, or there are many systems, and you can put on the top of the cover with the clay, and then the grass can grow. So you can see that one system will also study more about the design and analysis of the landfill. I will focus on one of my chapter, so I am not going detail about this landfill system here. So wet landfilling, that is bioreactor landfill. Rate of decomposition of organic waste in a dry landfill is not satisfactory, and the leachate will continue to contain the significant amount of contaminant many years, that is more than 20 years after the landfill is encapsulated. Many researchers also express skepticism regarding the longevity of the liner and leachate collection system. It is required to flush out the contaminant faster using biodegradation of the waste. Wet landfilling, where liquid is purposely added to the waste mass, can enhance the degradation process. The wet landfill strategy are leachate recirculation, anaerobic bioreactor, and aerobic bioreactor. You can see here that on the landfill system, this is the leachate, here is the leachate collection, there is a drain, and this drain is out through the pipe, and here you can leachate is storage, and again this leachate is recirculated through this pipe here. So this leachate is recirculating here, and from this you are also providing some cover and also the drainage, and you can see from this you can generate the gas. Gas can be extract from here, so you can use for the electricity, also you can use for the cooking gas by the leachate recirculation system. Now geocentric application for protection against falling stone. You can see that any hillside area where there is a possibility for the stone falling, and then that if there is a road, car is passing, there will be lots of problem. You can see also in Pune road also that where Konkan railway also you can see this kind of the problem. So you can provide with the mechanically stabilized reinforced soil wall which can protect the falling the stone. So you can also protection against the falling the stone. You can see the car can move the safety. So how this geocentric system can be used to protect the falling stone. Now the geocentric application for noise reduction barrier. Most of the time you can see that both sides of the road something car or vehicle is passing, there is a lot of the noise, but you can provide with the mechanically stabilized reinforced soil wall which can act as a noise barrier. So any sounder system is goes and reflect it back. You can also use the geofoam material, and you can see if there is any house, so they will not be disturbed due to the noise, so they are on the safe no noise, and this also very cheaper with respect to the conventional system. So here we are showing that how the geocentric material used as a noise reduction barrier. Now geocentric application to combat mitigation act of the terrorism and or natural disaster. Geocentric can be used as a retrospective geotextile tube filled with the sand can be dumped from the truck into the emergency sealing of leaf break. The military people can use the geotextile tube filled with the soil as blast resistance barrier wall. The fiber reinforced soil tube can be used as resistant to blast. The polyurea liner can be used for retrofitting building. Sometimes you know there is a possibility for attack for terrorism in the building or any place. So you can provide the wall proper kind of polyurea lining which can protect the building from the retrofitting and also building from the terrorist. Geosynthetic based barrier can be used for building security. The biological agent can be added to the slurry to obtain the potable water. Geosynthetics can be used as camouflage. Geosynthetics net can be used to evacuate the people from the building rooftop. So you can see that how this geosynthetics can be used in the various activity. Sometimes in the terrorism case you have to provide proper kind of the geosynthetic system in the building. You can also make the green building. There are different types of the system you can make. Green building will be the green, and also you can make the greenery surrounding area using this geosynthetic system. Then you are not to pour the water for many days, so the plant can survive. Nowadays lot of green building are coming up. What is International Geosynthetic Society? I am showing these slides a few milestone. 1977 first international conference on geosynthetics held in Paris and France. Initial its name was the first international conference on the fabric, but we consider this as a first international conference on geosynthetics. 1992 second international conference on geosynthetics in Las Vegas, Nevada, USA. 1986 third international conference on geosynthetics in Vienna, Austria. 1990 fourth international conference on geosynthetics, The Hague, Netherlands. 1994 fifth international conference on geosynthetics in Singapore. 1998 sixth international conference on geosynthetics, Atlanta, USA. 2002 seventh international conference on geosynthetics in Nice, France. 2006 eighth international conference on geosynthetics, Yokohama, Japan. 2010 9th international conference on geosynthetics in Sao Paulo in Brazil, and 2014 10th international conference on geosynthetics in Berlin, Germany. In 1985 we come up with the International Geosynthetic Society newsletter, now edited by Professor Braus from Germany. And you know that we have the two international journals, that is International Journal on Geotextile and Geomembrane, and the second journal is Geosynthetics International Journal. Initially it was named also Geotextile and Geomembrane. Then there is a lot of debate, discussion about geotextile, geomembrane, natural material, jute, coir. So ultimately we covered that entire system should comes under the umbrella of geosynthetics. That's why the second international conference journal has come with Geosynthetics International Journal. We have the total international geosynthetic chapter about 37, and particularly for the student membership is free. So you can make use of this society's benefit. What is the role of Indian Institute of Technology, Bombay? 1985 you have an undergraduate and postgraduate course on geosynthetics. 1985 Geosynthetic Research and Testing Laboratory. 1986 we make a video film. The title of the film is Geosynthetics Age. 1988 that is the first Indian Geotextile Conference under the auspices of International Society for Soil Mechanics and Geotechnical Engineering and International Geosynthetic Society. 1988 founder of International Geosynthetic Society Indian chapter in IIT Bombay. This is all in first times in India. And 1989 video course on geosynthetics engineering. 1993 turning point program on geotextile in TV. In 2004 international conference on geosynthetics and geoenvironmental engineering. From IIT there is a editorial board member of International Journal of Geotextile and Geomembrane from India. in IIT, that is the first time editorial board member in International Journal of Geotextile Geomembrane, and we have a many continuous educational program, workshops, seminars, etc. have been conducted. Many innovative research, testing, consultancy projects have been completed, development of new material and software, 2 books, Geosynthetics World and a guide to the geotextile testing, more than 400 technical papers on geosynthetics have been published. This slide source from International Society Soil Mechanics and Geotechnical Engineering Bulletin, volume 6, number 1, probability of failure. If you look this activity and the probability of death, you can see from the heart disease it is 0.25, cancer 0.23, stroke 0.036, car 0.012, suicide 0.09, fire 0.009, airplane 0.0002, bicycle 0.0002, lightning 0.0001, earthquake 0.00009, flood 0.00007. You look at this chart, this is the probability which have been given, that we are spending much more money maybe on the earthquake also related problem where probability of death is less, but you can see that in some of the civil engineering infrastructure the probability is less than the medical and others. So with this I just finish my today's lecture. Please let us hear from you. Any question? Thank you for listening.